Hello, my name is Dr. Richard Venditti, and we're going to talk about why we can recycle paper in this lecture. Okay, so some learning objectives. First, we're going to learn about what is a hydrogen bond. Then we're going to take a look at wood fibers for paper making. And then we're going to answer the question, why is paper recyclable? We're going to then discuss what happens to the strength of paper after it's recycled, and then we're going to look at, in an industrial operation, how we disperse paper fibers to prepare them for recycling. Okay, so the first thing we want to talk about is, what is a hydrogen bond? Hydrogen bonds are really, really important. They occur when you have molecules that have an electronegative atom, like nitrogen, oxygen, and fluorine, and also hydrogens. In this example right here, I'm showing two water molecules. And what happens in a water molecule is the oxygen, the O, turns out to be slightly negative. So we put a little partial negative symbol there to indicate that it's partially negative. It's a electronegative atom, so it becomes partially negative. And then these hydrogens are actually become partially positive. So we get partial positive charges on the hydrogens. And so what happens is, and I'll draw that here too, partially positive, this is going to be partially negative. Okay, so what happens is the hydrogen bonds occur between the negatives and the positives. So I'll just draw in dashed lines the hydrogen bonding between these two molecules. So the hydrogen here is bonding with that oxygen, and that oxygen is bonding with that hydrogen. And this actually causes these molecules to come together and can change the properties. So for one example, the boiling point of water is high because of all this hydrogen bonding between the molecules. And actually, this is the basis for life on Earth. It's been said that if we didn't have hydrogen bonding, we wouldn't have water and we wouldn't have life on Earth. So very, very important. Okay, so now let's talk about paper and hydrogen bonding. So the picture on the left is a microscopic picture of paper, and you can see that all paper is this random laydown of fibers. And what happens is, if we take a look right about here, we'll see that those fibers are bonded together. So those fibers are about 1 millimeter long and maybe about 0.030 millimeters in width. And if we take that and we look right here, what we can see is those fibers connect at some area where they're bonding. And then if we look even closer at this bonding area, what we'll see is that the fibers actually, chemically, they have what OH groups on them, on their surface. And those OH groups can form hydrogen bonds between the fibers. So I'll just draw that here. So this oxygen, which is negative, can hydrogen bond with that hydrogen. And then this hydrogen, which is partially positive, can bond with that. Now these fibers have multiple OH groups. So it's the surface of a fiber is decorated with many, many OH groups. And actually, it's this hydrogen bonding between fibers that causes our paper to have great strength. In fact, paper is stronger than steel, on a per weight basis. So the tensile strength of paper is extremely strong. So if I start to pull like this, what's holding that paper together is those hydrogen bonds. You can't see them, but that's what it's doing. Now another interesting thing is, if I just snap the paper like this, we can hear those hydrogen bonds. So those hydrogen bonds make the paper stiff, and it gives it that nice rattle noise. And that's hydrogen bonding. So we can actually hear the hydrogen bonds in the paper. So that's how paper actually is bonded together and stays together. All right, now why is paper recyclable? Well, the idea here is that the hydrogen bonds that are holding this paper together, when the paper is exposed to water, the water comes in and it infiltrates the paper, and it actually goes to those bonding sites. And what might happen is the water will go and it will disrupt the hydrogen bonds that had been there before. So let me just kind of draw water molecule. So we've got a, let's say, an O here, and we've got a H here, and then we've got maybe another H here. And what you see now is that that water is going to disrupt the existing hydrogen bonds between the fibers and set up new ones. Okay? And that's the disruption that allows the fibers to be separated when we put them in water. And that's the basis of paper recycling. We add water, the water goes in, it breaks those hydrogen bonds, and then the fibers can be separated. And once they're separated, we can start to recycle them. Now, here's an example. So I'm going to take our sheet of paper, and I'm going to dunk it in the water. Okay? Now, a couple things are going to happen that I want you to notice. First thing is, when I snap it, do you hear the difference of that snap? It's not really loud and sharp like before. What's happened is those water molecules have weakened the bonds, and now we can't hear the hydrogen bonds. Okay, so water, liquid water hydrogen bonds we can't hear. Then the other thing is, if I just pull very easily, you can see that the paper breaks apart. Okay, and if we continued this, we would liberate all the individual fibers that are in this paper. So that's just a great example that shows you that we're removing the hydrogen bonding, and that allows the paper fibers to come apart. All right, now why are plastics not recyclable like paper? Well, plastics don't have hydrogen bonding as their bonding. Plastics have carbon and hydrogen, but there's no electronegative atoms, so there's no hydrogen bonding. And basically, when water is exposed to, plastics are exposed to water, the water doesn't want to go into the plastics and separate the molecules or particles that make the plastic. So plastics cannot be recycled like paper because they don't have this reversible hydrogen bonding. Okay, now we can talk about paper strength on recycling. So when we have paper like this, like I said, it's stronger than steel on a mass basis. It's incredibly strong. And when we do recycling, we're going to wet it, slurry up the fibers, and then remake another sheet of paper. And what this graph is showing is that the recycled paper, its strength goes down slightly compared to the virgin paper. So on the bottom here we have number of recycles, and 0 would be the virgin paper from wood. And then every time we recycle, we have a little bit lower strength. So the strength decreases over 5 recycles is about 15 to 10%. But this is sufficient enough to make recycled paper. And if we add starch or do some process conditions a little differently, we can overcome that slight strength loss. But the point is that recycled paper has sufficient strength so that it can be used in multiple recycles for lots of different applications. Now, the other thing I should mention is every time we recycle, we lose a little bit of fibers. So some of the fibers get lost in the water. Some of them are broken a little bit and they get washed out. And so really the limiting factor of using paper in recycling is how much of these fibers we lose in making the recycling and removing contaminants and making new paper. It's more about that yield rather than strength decreases. Okay, so now let's talk about how we disperse paper for a commercial operation and starting the recycling process. So here's a nice picture. These are bales of OCC, old corrugated containers, getting ready to be recycled. And I'm just going to draw a person here. So I'm drawing them about to scale. And what you can see is that these are massive, massive amounts of recovered paper that we have to store and use as a process. So most recycle mills will use 100 tons per day, up to maybe 600 tons per day of recovered paper. So those bales actually get picked up with a little bobcat, and then they get put on a conveyor to go into what we call a pulper. Here's a picture of a pulper, and what you see here is that these are the bales falling into the pulper. The pulper is probably about 20 feet wide, very big, and on the bottom there's an agitator. And what we do is we put water in, and we put the bales of recovered paper, and then the agitator spins at the bottom just like a blender, and it tries to disintegrate the paper and liberate the fibers with the water, like we said. Now I want to show a video of a paper recycling pulper. This one is from Sunoco in Hartsville, South Carolina.
This pulper in particular we call our number 12 pulper. We generally are running a combination of mainly OCC, where we mix in some tube scrap and cone scrap, and then also some mixed paper in order to lessen our fiber cost.
All right, let's go look at the pulpers.
All right, let's do that.
All right, we're right here near the pulper, and Ryan, can you just kind of tell us some of the important operations that are going on within the pulper now?
Yeah, absolutely. So here's our number 12 pulper. It's a 20-foot pulper. Currently, what's basically going on is you have really a blender-on type operation, if you want to call it that. It's the simplest way to think of it. As the fiber falls into the tub, we're adding in water. We're adding in some recirculation from some of the screens, some of the other rejects, and you see a rag coming out. The rag tail is actually helping remove a lot of the wire and whatnot, tape, anything long that can string up on that tail. But really just trying to create turbulence so you can start breaking some of those H bonds inside the fiber. Not a whole lot of science, a whole lot of rocket science here, but this is really where the recycling starts to really begin.
Okay. Now, what consistency is this pulper at approximately?
Without looking at the actual DCS system, I'm assuming he's probably running at around 3.5 to 4% consistency now. We'll dilute that down running through our stock pumps as we feed it to screens, but just kind of an eyeball test on that.
Okay.
So this shows a cutaway version of a pulper. And what you can see is that the furnish, the recovered paper, will come up the conveyor and go into the pulper. And then we'll have water coming also into the pulper. And those two are blended at a certain ratio such that we can get a consistency. And in the paper industry, what we call consistency is the amount of solids divided by the total amount. And the total amount would be solids plus water. We usually express it as a percentage. And for a pulper like this, let's say 5% is a reasonable, normal type of consistency. And so how the pulper works is the recovered paper comes in, the water comes in. It comes in continuously. And then the paper gets broken up and dispersed into its fibers from the rotating rotor right here. And what will happen is there's a screen plate on the bottom that has holes in it. And when the fibers are liberated, they will be able to fit through the holes, and then they will go out the bottom, and that will be kind of our access. And the unpulped material, the large chunks of materials, they stay in the pulper until they're broken up, and then they can fit through the hole. So we're continuously adding paper, and we're continuously taking the pulped fibers out of the bottom. Continuous process. Now this picture right here just kind of shows a little bit more about the pulper side view. And what we have is a ragger. So when the bales go into the pulper, they go in with the wires and plastics. And what happens is you throw a rope into the pulper, and the wires and plastics wind up on that rope. And if you pull the rope out slow enough, then the wire and plastics, they grow. So it's kind of like a magician's trick where they're pulling a scarf out of their sleeve, and it never stops. Well, if we pull slow enough, then we just continue to pull out the plastic and wire that's wound onto that initial rope. And that's a really nice way to get a lot of the gross contaminants out. Some of the other larger stuff actually gets thrown to the side of the pulper and goes into this little tower. And that tower actually has a claw that will pull it out. So some large contaminants you might pull out with that. Okay, so just kind of to summarize, hydrogen bonds are what fibers and paper is used to keep the paper together. Okay, I'm going to start over again. All right, I'd like to summarize now. First thing we learned about was hydrogen bonding, and we found out that hydrogen bonding is responsible for paper having its strength. And the other thing we found out about is we add the water, and that actually removes the hydrogen bonding and allows the paper fibers to separate to be recycled in different operations. We also learned that the recycled fibers, when they remake paper, they're slightly weaker than the virgin fiber paper, but we can add starch and do a couple other things, and we can get very suitable paper properties from recycled fibers. We know, can recycle paper fibers many times. And in fact, strength isn't really the limitation. It's more about yield. Every time we recycle paper, we lose a little bit of our yield and of our fibers, and that really limits the amount of times that a fiber actually gets recycled. And then finally, we looked at an industrial pulper, and we understood that water and recovered paper are added, and then continuously we're pulling out dispersed fibers out the bottom. And then the pulper also has another job to remove gross contaminants to protect downstream operations. And that concludes our lecture on why we can recycle paper. Thank you for your attention.